We're about to start our second talk. Hello, we're about to start our second talk, so yeah. There's a lot more time for chatting afterwards. Okay? For the second talk, I will be giving the talk. So good evening. My name is Gordon. Today I will be talking about complex event processing, some use cases for complex event processing, and FlinkCEP, which makes this all possible and very easy. I'm the main co-organizer, self-introduction, I'm the main co-organizer of the Apache Flink Taiwan user group. And you can actually, I'm actually the one who hosted this event and makes 90% of the posts on the Facebook group. And from my profile pic, you might remember me, my hair is actually quite long. But now it's actually very short because I just left military service, I just left military service one month ago, and I just left. So I had to have my hair shaved. So yeah, today's FlinkCEP. Actually, I think this is quite a suitable topic to follow right up after Robert introduced the main building blocks of Flink, how it provides windows, out of order events, state handles. Because the way I see Flink release CEP, actually I knew Flink. I got interested in Flink because of CEP. I'll tell a story about this just in a while. The way I see CEP is it's a showcase of all these features that Flink offers. Out of event order, etc. All those events, all those features. Because without those features, we would not have a CEP library that will work as expected. Yeah, I'll get into more of this just in a minute. So what this talk is about is, first of all, the story of how FlinkCEP got me interested into Flink. And I'm not trying to exaggerate anything here, because this is a true story. This is a very true story. I'm not trying to preach how Flink is really good and you should use it, because yeah, you'll know it in a sec. And two use cases that we'll be going through for CEP. The first use case is called tracking the order process, which is commonly seen in e-commerce domain applications. E-commerce. This case study is actually borrowed from Data Artisan's, one of Data Artisan's presentations. And this use case study, advertisement targeting, is actually heavily based on my experience at the M5. We're trying to build a data platform and an ad tech platform for targeting, which we'll see in a sec. And while we study these two case studies, we'll also take a look at FlinkCEP API throughout the way. So a little bit more about me and Flink. Gordon, I'm currently working as a data engineer at the M5. I'm mostly proficient in Java and Scala. And I'm using Flink as a user on the M5's ad tech platform. I enjoy working on distributed computing systems. I don't really do this much right now in my current position, but I really like to dig in how these computing systems work and learn from the code base. I work on Flink during my free time. I try to contribute to it, and recently I just contributed the Flink Kinesis Consumer Connector, which will be available in the 1.1 release. Right. Okay. So let's start with the story. I tell the data engineer, aka this is actually me, trying to figure out. Oh, by the way, if you think I'm talking too fast or have any questions, you can just interrupt me by raising a hand. Okay. So a data engineer trying to figure out how to build up streaming analysis and analytics pipeline. And this was 1 year ago. So the situation I'm trying to elaborate here is 1 year ago when I didn't know Flink. First lesson, all non-trivial streaming applications are never stateless. This is something that actually everyone knows. If our streaming application is trying to draw some insight, there's no way that it's stateless. And the second lesson is that stateful streaming topologies are always a pain. Without the right tools, this is very hard to deal with because we have to deal with exactly once updates. We have to figure out, okay, we're using a stateless system. So how are we supposed to maintain our state and make our state reliable? Applications I was working on at the time was streaming aggregation for reporting and conversion patterns for alerting. As you know, I work at VM5. VM5 is an advertising company. Well, some part of it is an advertising company. And some people may ask, reporting, why do you have to do streaming for reporting? We can use batch. We can produce reports every hour. So this is crucial for the advertisement domain because advertisers who buy a campaign, they would like to know the performance of a campaign that they just bought. So they would like to know right now the performance of the campaign that they just bought, and if it isn't performing well, they'll take off the campaign and say, okay, we stop advertising this particular campaign. So this is very important. And I had to deal with all of these at the time. And some of these terms may seem familiar from Robert's talk just then. Exactly one state updates on failures for correctness. Idempotence with respect to external state stores. So at the time I was using Storm. And Storm, like Robert just said, it's a stateless system. It doesn't help handle state for you. So you have to use an external system to write your state, just in case your Storm topology fails. But if you're doing that, and if your Storm fails, at some point you have to replay. On situations you have to replay. But when you replay, you have to have idempotence write to external store. Out of order events, this is the hardest. Because this really messes up the application logic. When you have to, in your custom logic code, you have to write code to handle these things, these out-of-order events. It's really complicated. It messes up the code. The fourth part, aggregating on time windows. Just from this list, we can see like different kind of states. This is one state that we might have to deal with. And this is also some other kind of style of state that we also have to deal with. And combining 1 to 4 or 5, we have to develop applications at a rapid pace. What does this mean? It means if for ad hoc queries, SQL, we can perform ad hoc analysis on the data. But if we're writing a streaming application that's constantly generating reports, we have to write a streaming topology that runs for a long time. And a lot of times the business units people or the analysts who wants to gain insight from the data, they'll ask, okay, so can we also have a report, a new column, a new aggregation on the column that this reporting pipeline is generating. And this almost all the time always requires a lot of more work to do to develop a pipeline that fulfills all these. So I told you a lot about all this, and it isn't fun at all. This is actually the architecture, just a proof that actually really happened to me. So this is a reference architecture that I gave at HadoopCon 1 year ago. And it was called Building a Stream Processing System for Playable Ads Data at VM5. And so the architecture here seems rather simple. Redis was used as an external state store, but actually all these arrows took a lot of work to make it work as expected. So, complex event processing. I was talking about streaming aggregation and how streaming aggregation itself led to a lot of complexities. And complex event processing is also a emerging application in the streaming area and for streaming analytics, because the definition of complex event processing is we generate derived events from specific patterns in the raw events. So what this means is if A happens and then B happens, then we infer C. For example, you'll see in the following example, if an order is received but this order is not, and then an order is processed, we would, but then an order is not processed, we would infer that something has happened, something has wrong with this order reception. So the goal of this complex event processing is to identify meaningful event patterns and respond to them as quickly as possible. Demanding on, and what the hard part about this, like I just said, to perform stuff like this, we have to, for example, just take this sentence as an example. We have to keep a state of A, and then we have to wait until B actually happens, and then C. So we have to make sure the state that the CEP processing or this pattern matching it is keeping is correct, and it's always exactly once updated. So it is actually very demanding for the stream processor to be able to develop or to deliver a CEP library. And so FlinkCEP is possible because of all those merits. It's built upon Flink's data stream API. Allows users to define patterns. This is how it works. Users define patterns, inject them on existing streams, and then the stream generates new event streams based on the pattern. So in a way, we're using our raw events to generate more complex events. And then you can do whatever you do with data streams on the newly generated events. And it exploits Flink's exactly one semantics, state handles, and out of event order features, all of that for definite correctness. Okay, so the use case study, first use case study is order process tracking. The illustrations here, like I just said, was borrowed from this presentation from Data Artisans. The first we're going to go through is this scenario. So this scenario, we have a customer who ordered something. It might be buying something on Amazon, PC Home, buy something. The order is received at the warehouse of an e-commerce company. Okay, I receive this order, and then I ship this order. And after I ship this order will be delivered. So 3 events: received, shipped, delivered. This is the data model for this. And you can perform your usual stream SQL, stream aggregation on the stream, but we're not going to cover this tonight. I want to just go to, okay, what if we want to do SLA warnings? Say that we received an order, and then we shipped it, but somehow, after a period of time, we still haven't received this. And this is about to break the service level agreement of how long it should take for order ship to customer. For example, for PC Home, they guarantee 6 hours. But what if it's almost 6 hours or it's almost 5 hours, and we want to warn that this is going to exceed. So the CEP way of thinking is we have to infer new events from the raw events. The raw events are these. These are the raw events. We infer new events, process success, process warning, delivery success, delivery warning. These are not raw events, these are inferred from a pattern. And we define the pattern that processes, that generates these. So this is complex event processing. This is the API. It's actually very, very easy. I didn't want to jump into this right away tonight because actually the API you can check it out on Apache Flink's documentation, and they're really quite well written. But so now we're at this point. Basically, what this is doing is you can look at that diagram over there. We have a process order shipped event, and if within an hour we receive the order delivered event, then we'll generate a process succeed event. If after an hour we still don't receive the order delivered event, that means something went wrong with the shipping. So we want to generate an event to do this warning. So the first time here, processing pattern. What this is basically doing is, like I said before, users first define a pattern. A pattern is actually a build-up of states. So the first state is defined by being, okay, the pattern begins with an event of type order. This is actually it basically says is the naming of the state. So you can actually arbitrarily name this into any kind of name you want. So I named this is named order received here. This is called this state, and this state is triggered by when we receive an event of order. Then another kind of state you can define. There's actually a lot of other state definition types. You can define a strictly following. You can next by next. I forgot the actual API, but this actually means this event, this state doesn't have to happen exactly right after this one. There can be other events in the middle. So followed by, we name the state order shipped, where status equals shipped. This is, does everybody know Scala? Okay, well, I'm not that very good in Scala, so I actually get confused with this a lot. But what this means is whatever the event we get, and the status equals shipped, because if we call here, shipped, then this state is triggered. And then we define that this has to happen within 1 hour. So this pattern has to happen within 1 hour. Then what we do is simply, we call CEP.pattern, and then we give the input stream. This is the raw input stream, raw event stream, and this is the pattern that we want to inject onto the stream. Then this is the results. The result is either a process warning or process success, like I said. And then we use select function. What this is doing here is actually this is actually using an overloaded version of the select function, where you give two functions. The first function, in the first brackets, is the timeout handling function. This is called when this 1 hour is exceeded. So we received a begin, but then we did not reach this state within 1 hour. If so, this function is triggered. So we emit a process warn. If this is matched, this pattern is matched within 1 hour, then this select function is executed, and then this is the process success. So basically, this is what happens. And what we get here as a result is a process result for this stream. What we want to do with this process result in the following afterwards is up to you. We can continue to do SQL, we can continue to do another pattern on this generated inferred event stream. So this is kind of like the whole program, what it would look like. This should be familiar with people who already use Flink. Get the environment, we'll get the input, and we can add the source from maybe Kafka consumer or other consumers. We get the data stream. We define pattern. We CP, inject this pattern on the input. And then we have a result. This result consists of events inferred from this pattern. And then we can use this process result to do whatever we want to do. We can add it to the sink with the sink, we can add it to the sink, maybe to Kafka again with Elasticsearch. Or we can continue to transform it with back functions, with that functions. This is very powerful, in my opinion. And execute. And so if we want to use event time, what happens is basically we tell the system to use, okay, our topology is going to use event time. And then input, we extract event times from this input stream. And the rest is the same. Then now the whole topology is using event times. Okay? This is actually extending because I want to elaborate how this is very powerful. So, like I said, you can use the CEP process generator stream to continue with further processing. You can combine stream SQL with CEP. For example, these crayon colored lines here, what these mean is that they infer new CEP events. But we can also aggregate on these CEP events. So what this means is perhaps in every hour, how many delayed events are there? And all this we are processing from the raw event stream. I'm not going to go into too much detail on this, but you can also read the further reading from this presentation here. Okay? Okay. For this, ad targeting based on user attribution, this is actually going to be more of an example of how we inject CEP into a working system and how we exploit it. Because this is, the example that I was giving here is more the topology. So first of all, before we go into the actual diagrams, a little explanation of what is ad targeting. So basically, in an ad targeting platform, you'll have an ad server. What this ad server does is you'll get requests from mobile clients or web clients saying that, okay, I want advertisement. What the ad server does, it has to determine in real time what is a suitable advertisement to give this to user. What is an appropriate advertisement to give from this user. The ad server holds an advertisement campaign pool. So it chooses from this pool and it returns the advertisement to the request. How do we define appropriate? The most basic way to define this appropriate is fulfill the targeting rules of each campaign. So the ad server will have a lot of campaigns. These campaigns will each have a targeting rule. And as long as the advertisement I give back to the request fulfills the campaign's targeting rule, then this is matched. Okay? So then how complicated this whole system needs to be depends on the targeting rules we are trying to implement. We get a better idea of with these content here. Fundamental campaign targeting rule types. So the most basic kind of targeting rule is target user's current location. For example, an advertiser, he bought a campaign and he said, I want to target people in Taipei. So only give this advertisement, let users in Taipei see this advertisement. This is what this is basically. This is basically what this is saying. The second part is I want to target people who are using tablet or phones. Now, this is fairly simple because I can determine what campaign to give right away on request. But this is harder. Target users past location trace. Say, I want to target users who were in Taipei at least once for the past 3 days. Now to fulfill this request, we have to look at historical data, the data that we kept. And the second part, target users entering or departing countries. This is actually a very commonly used targeting schema because, for example, if you are a company who wants to sell your souvenirs, then you want to target people who are entering, who are leaving the country, maybe back to their home. So the third example is target user specific attribution. What attribution means here is that the trace of a user action. I viewed web page A, and then I also use something else. This might mean something to advertisers. They think this has something to do with the brand that they are trying to sell. So they want to target these kind of users. And like I said, the difference between these two, this does not require event aggregation at all. The rules can be matched simply when I get the request, I decide. This we have to look at the historical events, but we cannot rely on batch aggregation for this because normally the request we have to return in it's like a standard 200 milliseconds that we have to return this request. Requires inferring complex events from patterns in raw event stream. What this means is, for example, this one. This is in itself a very CP strong example because if I detect a pattern where a user was outside the boundary and then he's inside the boundary, this infers the event that he is leaving the country or he is entering the country. So how this is done in architectural view is I'll need to just elaborate a bit on how the ad server works, the flow of the request, and then we'll go into the data warehouse part. So we have a web service that we collect web client requests. And the first action of this is an initial connection. When this initial connection happens, what we do is an ad targeter looks at the campaign pool. It decides, okay, this is only the basic, so we don't go to advanced yet. A targeter will look at the campaign pool and will calculate, okay, these campaigns are suitable for this request. We cache this. Then, in mobile, there may be consecutive fetch add requests afterwards. With fetch add, we simply fetch from what we pre-computed before. This is what happens. And then the third thing that happens is we track the events into the data warehouse. And this is sort of the POC that is happening right now at VM5. And we have an event bus service. And the event bus service either goes to raw logs or directly stream to Flink, and then bash read from raw logs. But right now, from this architecture, what Flink is doing actually is kind of doing ETL into end sources, and end sources provide the reporting analytics services. But this is how basic targeting can be done, because like I said, our targeting here does not need any historical event. But now if we want to support the advanced targeting rules, entering, departing countries, or based on user attribution, or 3 days into was in Taipei for the past 3 days, we want to support targeting rules like this. We need somehow a way to let the targeter tell Flink to infer events for the targeter from this raw event stream. This is only the high level. I'll go into the details just a bit. So we kind of need like a rule service. What this rule service is, we have in mind is I tell you to track a pattern for me. And then afterwards, I ask if a specific user fulfills this pattern. So what is happening, we have in mind is rule service, we inject a rule to start matching on event stream. This is how the service works. Right now we have a fixed pool of CEP rule templates. So what this template is doing is we have a template for entity part. We can parameterize the polygon that we want to detect entering and departing. And then we have a user attribution template. So when we inject a rule, we give the required parameters, and then this submits a CEP topology to Flink. And the CEP works on this raw event stream. Whenever this CEP detects that pattern is fulfilled, we want to cache a UID. Oh, sorry. The UID, the service also returns a rule UID. Okay, the rule that you just submitted, that you just requested, has this ID. And then when CEP detects this pattern, it generates a new stream. So this new stream is used to write to cache UID as key, and then this UID is user ID, and then rule ID as a value. And then this service is open to lookups for whether or not a UID has fulfilled a rule ID. Okay? I've actually left out a lot of other details. For example, where does this UID come from? But it isn't that relevant to what I'm trying to describe here. So this is basically how it works. So with this rule service inside the data warehouse as a service to the ad targeter, what this can do is whenever an ad campaign is registered to the ad server's campaign pool, the ad server also gives, also injects a rule, a pattern, registers a rule to the rules engine, to this rule service, and says, okay, start tracing this one. And then whenever mobile clients connect the blue line, whenever mobile clients connect to the web service, say, I want to connect, I want to start fetching ads, the ad targeter can use this user's UID and check whether or not it has fulfilled a particular rule. And the rule ID actually just, the truth is, it's also a lot less work and complication. Because actually it would be very nice to have a freestyle rule service. What does a freestyle rule service mean? Pattern matching across different event streams of an organization. I'm taking VM5 as an example again. VM5 has several product lines, and each product line has its own event stream. But in a way, the whole organization is centered around a single target for data analysis. So in a way, for BI, sometimes they want to say something happens in this product for this user, and then something else happens for the same user in this product. We want to draw some insight from that. But like I mentioned in the very beginning of this presentation, developing streaming pipelines for this is quite hard. And so it actually would be nice to have a freestyle rule service. There's actually a very similar use case for what I've been trying to describe here. King's actually the company behind Candy Crush, and they are an active Flink user. And I think this topic is actually going to be shared on this year's Flink Forward, right? So if you want to know more of basically what this idea is about, you can also look at this part here. So after this use case, I'll come to a closing of today's talk. Okay. So basically what I'm trying to elaborate here today is complex event processing is actually a very new way, and combined with other technologies such as Stream SQL or arbitrary transformations that Flink offers, it's actually a very strong combination. And I think it's a new way to draw insight from raw event streams. And FlinkCEP, it builds on the data stream API to make this possible and very easy. And I'll share 2 use cases today, but I'm sure there's actually going to be a lot more use cases that maybe even you have in mind right now. So, yeah, that's my sharing for today. Okay. I'm open for questions if you have any.
Yeah, what's your response time?
Sorry?
How fast was the response time?
The response time for the second use case? This part is very fast because what this is actually, we're using this cache to store the results of this. So once this is real time, and we write whenever the pattern is matched. So when we check, we're actually only checking this cache. So this is the only response time depends on the Redis response time, but that's all.
How many patterns do you have?
Patterns. For example, if we are supporting entering and departing a country, this kind of targeting rule for a specific version of our ad server. For every campaign that defines this targeting rule, we have a CEP topology on Flink. So depends on the number of campaigns that is currently in the ad server campaign pool.
So will you also be able to deliver a targeted app for the first request, or will you be able to deliver it only for the second and subsequent requests?
Yes. Right now the limitation is this pattern matching is only after this pattern starts. And it should also generate batch from here and then go there. But for certain rules, such as entering departing country, again, we don't require this. But for another pattern, like was in Taipei for the past 3 days, this we have to process a batch to actually generate the correct rules. But right now, we're only thinking of this.
Your rules are very crafty, right? So it's like lots of people sitting down making these rules. Do you do A/B testing before you do them, or?
A/B testing. Okay. A/B testing is actually another aspect. The way we look at A/B testing is whether or not a specific campaign is tied to a targeting rule makes this campaign targeting better. So the A/B testing isn't specifically on the targeting function, but is how we parameterize this function that makes this campaign has the best performance. Does that answer your question?
After the user.
Yeah, that's after. No? Okay. If you have any other questions afterwards, you can also come to ask. So for the end of today, I'm just going to make a little announcements for Flink to keep you updated on some events of the user group. I've actually seen some first-timers that I haven't seen the first time. Well, welcome for new community members, and these links are the normal place, the usual places that we are giving out information from next meetup, or generally information on Flink, which is mostly on the Facebook group. And upcoming Flink tutorials and talks on HadoopCon this September. Me and George, is George there? We will be giving this Flink tutorial. So if you're interested in Flink, or if you know any friends who are interested in Flink and want to learn, this will be very fundamental training. And there's also 2 talks this time in this year's HadoopCon that's based on Apache Flink. And the next meetup, this is still under progress of preparing, but what we have in mind for the next meetup is Apache Beam and Google Dataflow. And actually, all related in Flink in some way. So if you're interested, you can also come to the next meetup. We haven't decided on time yet, but stay tuned if you're interested. And big thanks to VM5, the space here. VM5 actually just moved here 2 months ago, and they actually, if you know any friends or other meetup groups who wants to use the space, this is actually open for borrowing. So if you want to use the space, you can just contact maybe me or anyone else in VM5 for the request. And so because of VM5 is supporting the space, which I'm just going to, so VM5 is hiring right now, a lot of engineers, and so if you're interested, you can also check it out. Okay? Okay, that's all for today. Thank you all for coming.